Now I want to fit my linear model. So one technique is directly to write down that entire X matrix, but we will not do that. We shall be clever. I will create a new variable which I call fit, and then I will write LM. You already know that stands for linear model. Now I will have to write down the measurement vector. In my case this is length, so I write length tilde, that is the approximate equality sign. Now what I plan to write after that is where the strange thing will happen. I will just write wet. So if I just write wet, it will understand it, except that I need to specify data equal to dat. Or I might just write dat, that will also do dat. Oops, dat. Let's understand what it means. It means that I am working with a data set stored in dat, and I am trying to fit a linear model to length in terms of the variable wet. We already know that R has the habit of appending a column of ones. This is going to help us here because we know that intercept column 1 1 1 1 1, we do not have to apply it ourselves. So just hit enter. R does not say anything, and you know for R no news is good news, so it has done it. Just to make sure that R is really working with the design matrix that we want, just check model.matrix of fit, and you will see indeed the first column is 1 1 1 1, second is 1.0 1.5 etc. We call them beta 1 and beta 2. R calls the first one intercept, the second one wet. So this wet is basically the coefficient of wet that it's trying to compute. Okay, so let's try to look at what is inside fit. I will type fit and I get the coefficients. So the least square estimate, beta 1 hat, the intercept happens to be 3.283, and beta 2, it says wet, it is the coefficient of wet. So it should not really say wet, it is the coefficient of wet, 2.010. So that is the unique least square estimate. How do I understand it is unique? Because I do not see any NA. If at least one of the coefficients is reported to be NA, I will understand that that is only one possible least square solution and it is not unique. In this case, it is unique and you have got it. Now when you do that, you get the least square solution, you must make sure that it is a good thing. So I should do something that I should have done at the very beginning. I should really not start to fit a linear model before I make a plot. I should have made a plot. Stupid me, why did I not make a plot? I should have always done a plot first. So I will just replay my command, plot length versus wet. Whatever you are writing before the tilde is your y variable, and whatever comes after that is your x variable, and it's not called pot, it's called plot. And you get this. Whoa, this is just straight line. So there is some amount of random variation, but you hardly see that. So this is very good. It just looks very, very, very nice fit. So yes, linear model in this case is a good fit, so you can really rely on the values. You can now try to play with it. You can try lines. And I will try fit. Oh, I should show you what's inside the fit variable. Try names fit. And fit has many things. Fit has got coefficients. It has got residuals, something called effect. You understand what is meant by rank of the design matrix. Fitted values, that's useful. Assign, I do not know what that is yet. QR, I do not know what that is. DF residual, wow. And some other things. So let's try certain things. Fit $coef. I abbreviated coefficients to coef. You can abbreviate as long as you do not run into any ambiguity. And these are the coefficients that we already saw. I can try to see fit $receipt or res. These are my residual vectors, that is y minus y hat. that perpendicular vector that I drew earlier. And what else? Okay, try fit dollar fitted values. Fit dollar fit. So this fit is an abbreviation for this thing, fitted values. Fit dollar fit. This is your y hat. That is the foot of the perpendicular. And try rank fit dollar rank. Rank of the design matrix X. In this case it is 1, 1, 1 and all those xi's, since not the xi's, the wi's. Since the wi's were not all same, so the rank of this matrix is 2. It is just reporting that 2. Okay, now what do you really typically want to do here? You would like to show the straight line on top of it. So let's just try to do that. I will say lines. Lines will do it, and then I will write fit dollar $quef. And let's take a look at the plot. Oh, I do not see the plot. What happened? I do not know. Okay, so it will not do that easily. Lines dollar fit will do it. Oops, no. I am doing stupid things, so I have to write separately. So there was a smarter way of doing it. Can't recall. So fit dollar $quef. The first entry. Remember, $quef is a vector of two things. The first is the intercept and the second is the slope. Now, oh, I remember the mistake that I did. I remember. I should call AB line. Fit dollar $quef. Yes, that's the thing. I forgot. And now it has given you the line. And you can see it is a very good fit. And that brings us to the end of this video.